Tonight, we drift toward a place where time moves in centimeters, and ancient ice remembers every winter that ever was. Somewhere in the high silence of the world, rivers are flowing, but so slowly that a human lifetime cannot perceive their motion. They are made not of water, but of compressed snow, pressed by its own weight into something denser, bluer, older than nearly anything you have ever touched. And as you settle into stillness, we will travel together to these patient giants, the glaciers, and listen to the long, quiet stories they have been keeping for us. Welcome to Let's Learn While You Sleep. Tonight, our journey takes us to the cold cathedrals of the earth, to the glaciers, those slow, luminous rivers of ice that drape across mountains and continents like sleeping creatures of light. We will explore how they form, how they move, what they remember, and why they matter to every living thing on this planet, including you. There is no need to follow every word. The science will move at the same patient pace as the ice itself, drifting forward in soft, unhurried layers. You may close your eyes whenever you wish, and let the words become a kind of weather around you, a gentle snowfall settling into the valleys of your mind. Breathe in slowly, breathe out longer, and as you do, imagine standing at the edge of a frozen field that stretches farther than any horizon you have ever seen, where the air is clean, the light is blue, and time itself begins to slow. Let us begin with what a glacier truly is. A glacier is not simply a field of snow, nor a frozen lake, nor an icy mountainside. A glacier is a body of dense ice formed over many years that flows under the pressure of its own immense weight. That last part is the key. Flow. Glaciers move. They are not still, no matter how motionless they appear to the human eye. They are rivers, but rivers made of crystal, drifting forward at speeds measured in inches per day, sometimes only inches per year. To form a glacier, a region must receive more snow each winter than melts each summer, year after year, decade after decade, century after century. The snow that falls in autumn does not fully disappear in spring. Some of it lingers, compressed beneath the snow that falls the following winter, and the year after that, and the year after that. Slowly, the lower layers transform. Light, fluffy snowflakes are crushed into rounded grains, and those grains, packed ever tighter, fuse into a denser substance scientists call firn. With still more time and still more pressure, firn becomes glacial ice, a substance so compressed that it carries a strange, deep blue color. Because the trapped air bubbles have been squeezed nearly out of existence, only the longest wavelengths of light, the warm reds and yellows, are absorbed by this ancient ice. The cool blues escape, and that is what we see. So when you look upon the deep blue heart of a glacier, you are looking at light that has traveled through centuries of compressed winters, refracted through frozen time itself. It is, in a very real sense, the color of patience. And across the world, in the high places where snow outlasts the sun, this slow alchemy has been unfolding quietly, steadily, for thousands of years, building monuments of ice that dwarf entire cities and outweigh entire mountain ranges. Now consider for a moment where in the world these slow rivers live. Glaciers exist on every continent except Australia, drawn to the high latitudes and the high altitudes, the cold corners where snow can resist the warmth of summer. The greatest of all are the ice sheets, colossal glaciers that bury entire land masses. There are two of them on Earth today, the Greenland ice sheet and the Antarctic ice sheet. Together, they hold roughly 99% of all the freshwater ice on the planet. The Antarctic ice sheet alone covers an area larger than the United States and Mexico combined, and in places it is more than 4 kilometers thick. That is more than 2.5 miles of solid ice pressing down upon the bedrock below. So heavy is this ice that it has actually pushed parts of the Antarctic continent below sea level, depressing the rock beneath it like a hand sinking into a thick cushion. Beyond the great ice sheets, there are smaller mountain glaciers, the kind that crown the Alps, the Andes, the Himalayas, the Rockies, and the mountains of Alaska, Patagonia, New Zealand, and East Africa. These alpine glaciers are smaller and faster, sliding down valleys, carving paths into the stone. And then there are the curious in-between forms, ice caps, smaller domes of ice that cover highland regions, ice fields, sprawling plateaus of frozen weather, and tidewater glaciers, those that flow all the way down to the sea, where their leading edges crack and tumble into the ocean as icebergs. Each of these forms is a variation on the same essential theme: snow that lingered long enough to become stone, and stone that learned, somehow, to flow. Together, glaciers cover roughly 10% of the Earth's land surface today. During the last ice age, which ended around 11,700 years ago, they covered closer to 30%. Our planet has been, for most of its recent history, an icier place than the one we now inhabit. And how, you may wonder, does a glacier actually move? How can something so vast, so frozen, so apparently solid, behave like a river? The answer lies in the strange physics of ice under pressure. Ice, when it is thin and cold and unburdened, behaves like the brittle stone we know. It shatters, it cracks, it splinters underfoot. But when ice is piled deep enough, perhaps 50 meters or more, the weight of the ice above transforms the ice below. Down in those deeper layers, the crystals begin to deform. They slide past one another in slow plastic motion, like extremely thick honey or like glass given enough centuries to flow. This is called internal deformation, and it is one of two main ways a glacier moves. The other is called basal sliding. At the bottom of many glaciers, a thin film of meltwater forms, sometimes from geothermal heat rising out of the bedrock, sometimes from the immense pressure itself, which lowers the melting point of ice ever so slightly. This water acts as a lubricant, allowing the entire glacier to slide forward over the rock beneath it, like an enormous frozen sled gliding on its own thin breath of liquid. The combination of these two motions, deformation deep within and sliding along the base, is what allows glaciers to flow. Most move very slowly, perhaps a meter or two per year, drifting forward as imperceptibly as the hour hand of a clock. But some are faster. The Jakobshavn Glacier in Greenland, for instance, has been measured at speeds exceeding 40 meters per day during certain periods, making it one of the fastest flowing glaciers in the world. And occasionally, glaciers do something extraordinary. They surge. For reasons not fully understood, certain glaciers can suddenly accelerate, advancing dozens or even hundreds of times faster than their normal pace, for a period of months or years, before settling back into stillness. They are alive in their own strange and patient way. They breathe in winter, exhale in summer, and walk forward across the ages on legs of liquid water and ancient pressure. There is something else glaciers do, something quietly miraculous. they remember. Locked within their layered ice are tiny bubbles of ancient air, actual samples of the atmosphere as it existed at the moment that snowflake fell to Earth. When scientists drill long cylindrical cores from deep within the Antarctic and Greenland ice sheets, they bring up records of climate that stretch back, in some cases, more than 800,000 years. The deepest ice cores recovered to date come from a project in East Antarctica, where researchers have sampled ice nearly 3 kilometers down, ice that froze before the first humans walked the savannas of Africa. By analyzing the trapped air bubbles, scientists can measure the precise concentrations of carbon dioxide, methane, and other gases at countless points across that immense sweep of time. By examining the ratios of certain oxygen isotopes within the ice itself, they can estimate ancient temperatures. By looking at the dust embedded in different layers, they can identify volcanic eruptions, drought periods, and the rise and fall of distant deserts. A single ice core is, in effect, a frozen library, page after page of compressed winters, each one a chapter in the long autobiography of the planet. And what these libraries tell us is humbling. They reveal that Earth's climate has shifted dramatically across the millennia, swinging between glacial and interglacial periods, sometimes gradually, sometimes within mere decades. They reveal that the current concentration of carbon dioxide in our atmosphere is higher than at any point in the past 800,000 years, according to data from these ice cores. They reveal patterns and rhythms, the slow Milankovic cycles, named after the Serbian scientist Milutin Milankovic, who proposed in the early 20th century that subtle variations in Earth's orbit and tilt drive the long pulse of ice ages. The glaciers do not speak, but they keep faithful records, and we, in our short and curious lives, have learned to listen by drilling carefully into their hearts and reading the silent testimony preserved within. Let us travel now to the great ice sheets, the largest glaciers of all, those vast continental coverings that dwarf every other expression of ice on Earth. There are two of them in our present age, two enormous white shields draped across the planet's poles. The first lies upon Antarctica, a frozen continent roughly 1.5 times the size of the United States, buried beneath ice that in places reaches nearly 4 kilometers in thickness. That is almost 2.5 miles of solid, ancient ice, pressing down upon hidden mountain ranges, hidden lakes, hidden valleys that no human eye has ever directly seen. The second great ice sheet rests upon Greenland, smaller than its southern counterpart, yet still holding enough frozen water to raise global sea levels by roughly 7 meters were it ever to melt entirely. Together, these two sheets contain approximately 99% of all the freshwater ice on our planet. Imagine that for a moment. Nearly all of the frozen freshwater of Earth gathered in just two enormous, slow-breathing places. And these ice sheets are not silent, not truly. They creak, they groan, they shift in their sleep with a deep, low voice of compressed time. Beneath them, in places, liquid water flows in dark subglacial rivers, lubricating the ancient base, allowing the ice above to slide imperceptibly toward the distant sea. There are lakes down there, too, sealed beneath the ice for hundreds of thousands of years, harboring forms of microbial life that have lived in total darkness, in total isolation, since long before our species even existed. Scientists have only recently begun to study them, drilling carefully through the ice to glimpse waters that have never known the sun. Consider what it means that beneath those frozen plains lies a hidden world, untouched, unhurried, unaware of our coming and going. A world where time runs differently, where stillness is not absence, but the slow, patient presence of something far older than memory. The ice sheets are not merely cold, they are deep, and they are listening. Now, let us turn from the great sheets to the smaller, more intimate glaciers, the ones tucked into mountain valleys all over the world. These are called valley glaciers or alpine glaciers, and they form wherever snowfall in high altitudes consistently exceeds melt, gathering year after year, century after century, into rivers of ice that descend the slopes with infinite patience. You will find them in the Alps of Europe, the Andes of South America, the Rockies of North America, the Southern Alps of New Zealand, and most majestically in the Himalayas and Karakoram of Asia, where some of the longest non-polar glaciers on Earth wind their way through valleys that have been carved by their ancestors. The Siachen Glacier in the eastern Karakoram stretches roughly 76 kilometers in length, a frozen serpent moving so slowly that on any given day you would see no motion at all. And yet it moves. It always moves. Valley glaciers are sculptors. As they descend, they carry with them rocks of every size, from fine silt to boulders the size of houses, embedded in their underside like teeth set in a vast, slow jaw. These rocks scrape against the bedrock beneath, grinding the mountain itself into powder, gouging out the characteristic U-shaped valleys that geologists recognize as the unmistakable signature of past glaciation. Where two glaciers meet and merge, dark stripes of debris run down the center called medial moraines, like seams in a quilt. Where the glacier finally ends, melting into water in the warmer air below, it deposits everything it has carried, building ridges of jumbled stone called terminal moraines, sometimes damming new lakes into existence. Yosemite Valley in California, the fjords of Norway, the lochs of Scotland, the Great Lakes of North America, all of these landscapes were shaped, in part, by glaciers that have since retreated or vanished entirely. The mountains we admire today still carry the fingerprints of ice that left long ago. The glaciers were here. They worked their patient stonework, and the world remembers. Within every glacier, deep within its layered body, there exists a quiet architecture of light and color that few ever witness. The ice, when freshly compressed and dense, takes on a remarkable shade of blue, a deep, glowing, otherworldly blue that seems almost to come from within rather than from any external source. The reason for this is a matter of physics, gentle and elegant. When sunlight passes into thick glacial ice, the longer wavelengths, the reds and oranges and yellows, are absorbed by the water molecules along their path. Only the shorter wavelengths, the blues, survive long enough to scatter back to your eye. The thicker the ice, the deeper and more saturated the blue becomes. Stand near a freshly carved iceberg or peer into a crevasse on a sunny day, and you will see colors that no painter has ever quite captured. A blue that feels less like a color and more like a sound, low and resonant, held for a long time in stillness. Beneath the surface of every glacier, water finds its way through the ice in surprising forms. Meltwater streams carve tunnels called moulins, vertical shafts that plunge from the surface into the body of the glacier, sometimes reaching the bedrock far below. There are entire cave systems within glaciers, blue-walled chambers where drops fall musically from the ceiling, and the air is so still it feels frozen in place. Explorers who have entered these caverns describe a hush unlike any other on Earth, a silence so complete that one's own heartbeat becomes audible. Above, on the surface, sunlight may dance and wind may rustle, but down here, in the heart of the ice, time slows almost to stillness. The walls glow with that impossible blue. Faint cracks and bubbles of trapped air shimmer in the half-light. And here, perhaps more than anywhere, you sense that a glacier is not merely frozen water, but a kind of cathedral, vaulted and luminous, built grain by snowfalls long since forgotten. A cathedral of ice, lit from within. And then, after centuries of patient travel, after carving valleys and grinding stone and storing memory, every glacier eventually arrives at its end. For some, this end comes high in the mountains, where the ice melts gradually into streams that feed rivers, rivers that feed villages, valleys, civilizations. The Ganges, the Indus, the Brahmaputra, the Yangtze, the Mekong, the Rhone, the Rhine, the Colorado, all of these great rivers depend, in part or in whole, on glacial meltwater. It is estimated that nearly 2 billion people, roughly a quarter of humanity, draw water in some measure from glaciers and the snowfields above them. The slow rivers of ice quietly sustain the fast rivers of life. For other glaciers, the end comes at the sea. Tidewater glaciers, as they are called, descend all the way to the ocean's edge, where their leading wall stands as a sheer cliff of ice, sometimes tens of meters tall, scoured and blue and trembling with internal stress. From time to time, with a sound like distant thunder, enormous slabs break free and tumble into the water, sending waves rippling outward. This is calving, the birth of icebergs. The great chunks drift away, floating with most of their mass hidden beneath the surface, slowly melting as they wander into warmer seas. Some icebergs survive for years before they vanish, traveling thousands of kilometers, carrying within them the compressed snowfalls of ages past. When they finally dissolve into the ocean, they release water that has been frozen for, in some cases, hundreds of thousands of years, water that last touched the open sky when mammoths still walked the tundra. There's a quiet poetry in this. The glacier, having spent its long life in patient descent, finally returns to the sea from which all water comes. Its journey, which began as a single snowflake settling on a mountainside, ends as a soft melting into the great salt waters of the world. A circle, gently closed. A long, slow breath, gently released. Consider for a moment the strange and beautiful phenomenon of glacial calving. When a glacier reaches the sea, it does not simply melt away into the water like ice in a glass. Instead, the immense pressure of the moving ice, combined with the buoyancy of sea water pressing upward against its underside, causes great slabs to fracture and break free. These fragments, sometimes the size of small cathedrals, sometimes the size of entire cities, tumble into the ocean with a sound that travels for miles beneath the surface. Whales, seals, and countless other marine creatures hear this thunder long before any human ear could detect it. The ice, having traveled across centuries from the high interior, finally enters a new existence as an iceberg, drifting on currents toward warmer waters. And yet, even now, only about 1/10 of an iceberg's mass rises above the surface. The remaining 9/10 hang suspended below, sculpted by the sea into chambers and arches and slow blue cathedrals of submerged light. Sailors throughout history have feared these hidden masses, for they are vast and silent and almost invisible. The Titanic, in April of 1912, struck just such an iceberg in the cold waters of the North Atlantic, and the tragedy of that night has become one of the most studied collisions in maritime history. But beyond their danger, icebergs are also profoundly beautiful. The ice within them, having been compressed for thousands of years, contains almost no air, and so the longer wavelengths of light are absorbed, leaving only the deep, glowing blues to escape back to the surface. Some icebergs, when carrying ancient sediment from far inland, appear striped, banded with dark threads of dust and rock that fell upon glaciers long before any human civilization existed. They drift now through cold seas like floating museums, carrying within them frozen memories of the world as it once was, slowly returning their ancient water to the cycle from which it came, a cycle older than mountains, older than continents, older even than the oldest forests we know. Let us now descend into the heart of a glacier, into the cold and luminous world that exists beneath its surface. To enter a glacier cave is to step into a chamber unlike any other on Earth. The walls are not stone, but ancient water, pressed and folded over millennia until every bubble of air has been squeezed away. Light passing through this dense crystalline ice is filtered of its warmer tones, and what reaches the eye is a soft, glowing blue, sometimes deepening into sapphire, sometimes lightening into the pale color of a winter sky just before dawn. These caves are carved by meltwater, by streams that find their way into crevasses and gradually widen them into tunnels and galleries. In summer, water rushes through them with surprising force, sculpting the ice into smooth ripples and gentle scallops, leaving behind passages that resemble the interiors of seashells, whirled and translucent and quietly humming with sound. In winter, when the meltwater slows or stops entirely, the caves fall into a stillness so complete that one can hear faintly the settling of the ice itself, small clicks and groans as ancient layers shift beneath their own weight. Glaciologists, the scientists who study these frozen rivers, sometimes descend into such caves to take measurements, to observe the structure of the ice, to listen for the hidden movements within. They wear helmets and warm gear and carry ropes, for the caves can change quickly, sealing themselves or collapsing as the glacier moves above. And yet, despite the danger, those who have walked through these blue chambers describe the experience in almost reverent tones, as if they had stepped into a temple, a place where time is held in suspension and where the ordinary noise of the world cannot reach. Imagine for a moment the soft echo of your own breath in such a place, the quiet drip of water from a distant ceiling, the gentle radiance of blue light filtering through walls of frozen centuries, surrounding you on every side, calm and patient and impossibly old. Glaciers are also among the greatest archives our planet has ever produced. Within their layered ice, scientists have found preserved bubbles of air, tiny pockets of atmosphere that became trapped when snowflakes first fell to Earth and were slowly compressed into ice. By drilling deep cores from places like Antarctica and Greenland, researchers have recovered samples of air that are hundreds of thousands of years old. The Vostok ice core, drilled in East Antarctica during the late 20th century, reached down through approximately 420,000 years of climate history. and the more recent Epica core extended that record to roughly 800,000 years. Within these tiny bubbles, locked away beneath crushing pressure, are samples of ancient air, breathed by mammoths perhaps, or drifting above forests that no human ever walked. By analyzing the chemistry of these bubbles, scientists have reconstructed the rise and fall of carbon dioxide, the slow rhythms of ice ages and warm periods, the great breathing of the planet across deep time. The ice itself, too, holds secrets. Heavy isotopes of oxygen and hydrogen vary, depending on the temperature at which the original snow fell, and so each layer becomes a thermometer, recording the climate of its birth. Volcanic eruptions leave faint traces of ash and sulfur, allowing researchers to date specific layers with remarkable precision. Even ancient pollen, ancient dust from distant deserts, traces of cosmic radiation from supernovae long past, all of it has been found preserved within the patient body of glacial ice. To read a glacier, then, is to read the diary of the Earth itself, written not in words, but in chemistry and crystal and trapped breath. And as you drift now towards sleep, consider the strange wonder of this. Somewhere on this planet, deep within a frozen mountain, or beneath miles of polar snow, there exists air that has been waiting, undisturbed, since long before any human language was spoken, since long before the first cities rose, since long before our species had even learned to dream beneath the stars. And what of the life that depends upon these slow rivers of ice? Across the world, glaciers are not isolated wonders, but living parts of vast ecosystems that have grown around them across countless generations. The meltwater that flows from a glacier in summer feeds rivers, and those rivers feed forests, farmlands, and entire civilizations. The great glaciers of the Himalayas, sometimes called the Third Pole because of the immense quantity of ice they hold, give rise to rivers such as the Ganges, the Indus, the Brahmaputra, the Yangtze, and the Mekong, which together provide water for well over 1 billion human beings. The glaciers of the Andes feed cities high in the mountains of South America. The glaciers of the Alps shape the rivers that flow through the heart of Europe. Even smaller glaciers, tucked into remote valleys, sustain alpine meadows, cold streams, and countless species of plants and animals adapted to the cool, mineral-rich waters. Within glacial streams live tiny creatures called stoneflies and caddisflies, organisms so specialized that they can survive only in the cold, oxygen-rich water that comes directly from melting ice. Higher up, on the surface of the glacier itself, scientists have discovered ecosystems of algae, bacteria, and microscopic invertebrates such as ice worms, slender creatures that thrive in temperatures near freezing and would die from the warmth of a human hand. Some glacial algae bloom in such numbers that they tint the snow pink or red, a phenomenon known as watermelon snow, observed for centuries by mountaineers and noted as far back as the writings of Aristotle. These tiny lives, hidden upon and within the ice, form an entire community that the rest of the world rarely sees. And so, a glacier is never simply a piece of frozen geography. It is a slow, living engine, breathing meltwater into rivers, feeding microscopic forests on its surface, sustaining valleys and cities and civilizations far below, connecting the high silence of the mountains to the rhythms of life that unfold across the warmer, lower world. Consider for a moment the slow and patient way a glacier shapes the very face of the Earth. Where ice rests upon stone for thousands of years, It does not merely sit there in stillness, but presses down with enormous weight, grinding the rock beneath into fine powder, plucking boulders from the bedrock and carrying them forward in its frozen embrace. Geologists call this process glacial erosion, and across millennia it has carved some of the most dramatic landscapes our planet has ever known. The deep U-shaped valleys of Norway, the great fjords of New Zealand and Patagonia, the soaring cirques of the Alps, the polished domes of Yosemite, all of these were sculpted by the long, slow passage of ice. And yet the glacier does not only carve, it also deposits. As it melts, it releases the rocks and sediments it has carried, sometimes for hundreds of kilometers, leaving behind ridges of debris called moraines, scattered boulders called erratics, and broad plains of glacial till. Some of the most fertile soils in the world, including those of the American Midwest and Northern Europe, were laid down by the retreating ice sheets of the last glacial period, which ended roughly 11,700 years ago. The Great Lakes of North America, holding more than 1/5 of the world's surface freshwater, are themselves the basins gouged out by ice during that long, cold age. Somewhere in that quiet realization lies a profound truth that the soil beneath our feet, the lakes from which we drink, the valleys in which our cities rest, were all shaped by ice we have never seen. The glacier is, in this sense, not only a feature of the present, but a sculptor of the past, an unseen architect whose work surrounds us still. And though most of those great ice sheets have long since vanished, their fingerprints remain everywhere, written into the contours of continents in a script of stone and silence that the patient eye of geology has only recently learned to read. And now let us turn gently to the question of how glaciers are changing in our own lifetimes, for this too is part of their long and quiet story. Across nearly every mountain range on Earth, from the Andes to the Alps, from the Rockies to the Himalayas, glaciers are retreating. Scientists have measured this retreat carefully using satellite imagery, aerial photography, and direct field surveys, comparing the position of each glacier's terminus year after year, decade after decade. The evidence is consistent. According to the World Glacier Monitoring Service, glaciers worldwide have been losing mass almost every year since the late 1970s, and the rate of loss has been accelerating. The Greenland ice sheet, the second largest body of ice on the planet, is shedding hundreds of billions of tons of ice each year, and the great glaciers of West Antarctica are showing signs of long-term instability that researchers are still working to fully understand. The cause, current evidence strongly suggests, is the warming of the global climate driven primarily by the rise of greenhouse gases in the atmosphere over the past 2 centuries. And yet, the story is not a simple one of disappearance. Some glaciers respond quickly to warming, others very slowly. Some are protected by thick coverings of rock debris that insulate the ice beneath. Some, in places where snowfall has increased, are actually advancing, though these are now the exception rather than the rule. The slow retreat of ice carries consequences that ripple far beyond the mountains. Sea levels rise as glacial meltwater flows into the oceans. Rivers fed by glaciers may swell in the short term and dwindle in the longer one. Coastal communities, mountain villages, and ecosystems that have known these icy rhythms for centuries are now adjusting to a changing world. There is a strange and quiet poignancy in this, that something so ancient, so vast, so seemingly unchangeable should be transforming within the span of a single human life, reminding us that even the slowest rivers in the world are still, after all, in motion. And so we leave the glaciers for tonight, though they will continue, of course, to flow. They will move while you sleep and while you wake, and while you go about the small, bright errands of your days. They will keep their slow appointments with the centuries, pressing forward inch by patient inch, holding the breath of ancient atmospheres within their depths, gleaming softly under polar suns and Himalayan stars. There is something deeply restful in knowing this, that somewhere in the world, time is being kept by ice. That a snowflake which fell when the pyramids were new is only now, perhaps, reaching the lower reaches of a glacier, ready at last to melt into a stream and return to the sea. Let your breathing slow to the rhythm of that ancient drift. Let your thoughts settle like new snow on a quiet field. There is no hurry tonight. The ice has been patient for 100,000 years, and it asks nothing of you but stillness. If you would like to drift with us again into other quiet wonders of the natural world, you are warmly invited to stay. Thank you for spending your night with Let's Learn While You Sleep. Subscribe and come back tomorrow night. We'll be here. Sleep well.